Hello, my name is Daniel Doc Sewell, and this is the video of my walkthrough for the challenges that I wrote for DEADFACE Capture the Flag 2023. Now, these are just my challenges, the ones that I wrote, the ones that I worked on, that I created initially. It was a lot of work that went into these, and I like to pride myself on giving an interesting storyline where the challenges work together and where real world techniques that you might see in a real world pen test or malware analysis or website pen testing or incident response or something like that, that we tie those together into a real storyline and throw in some Halloween goodness and spooky fun along with it. So I really hope you enjoy this. I will apologize that for the issues I'm having with the windowing with OBS, where my window isn't getting lined up. I make like one video a year, and so it didn't get lined up properly. But I wanted to get this rushed out so that it would be ready for all of the people who want to go through the challenges at the end of the CTF, which ends in about another hour and 10 minutes. So I've been rushing like mad, pausing the video, jumping over, the making of the video, jumping over and answering questions that people have about my challenges and coming back. So it's been, and like I said, I didn't notice that the video got shifted out of sync on OBS until well in, like probably about 7 or 8 challenges in. So that's why some of them look a little funky, but you should be able to see everything. I did add some text hints in certain places, but really I'm not doing anything more with this video. I don't want to go back and re-record any sections. I just want to get this video out so that people have it and can be able to walk through the challenges and enjoy them. So anyway, let's get started with our first challenge. Let's take a look at reverse engineering Serial Killer 01. So the challenge says, how well do you know your DEADFACE hackers? Test your trivia knowledge of our beloved friends at our favorite hacktivist collective. We'll start with Bumpy Hassan. Even though he grates on TheZeal0t a bit, we find him to be absolutely adorkable. Choose one of the binaries below to test your BH trivia knowledge. Bumpy Hassan. Enter the flag in this format. And then here's your link to a Linux binary or a Windows binary. You can use either one. I've downloaded the Windows binary, and I'm using Windows and WSL to test things out. So this one's actually not that difficult. If you take the easy route, you could try to debug the application. I probably wouldn't go that route. The first thing I would do with any reverse engineering challenge is to run a strings on it. And I'm going to look for any kind of unusual strings here that might be of interest. And so I'm looking at that right there. That could be something. Goes the curly brace. That could be a string for flag and a curly brace. But actually, we see right here flag %s. So that tells me this is probably a format string, and they're going to probably put the flag in there. So this might be one of these other strings up here. Let's take a look and see if anything looks interesting. This looks interesting. We have this big long string here, and we have some characters here, but if we take a look, we see an I, we see an underscore, A, M, and we start to see a pattern. So one of the things that stuck out to me is right here. We can see the name Freddy, and that happens to be one of our serials, although it hasn't appeared yet on the scoring server. Freddy Krueger is a monster, just like, similar to Jason Voorhees, right? So you see Jason Voorhees right here. Freddy and Jason got into a big fight one time. So I'm going to look at this string here, and I'm going to skip every other character and see what I come up with. So let's just copy that string, and we'll drop it into Notepad. And we'll just go through here and take out every other character and see if a pattern starts emerging. See, I am ready for Freddy. And we saw that there was a flag tag around it. So let's add that. And so I believe it's going to tell me that I can't enter this because it's already been entered for me. So yeah, it'll probably come back with a response that says the flag has already been correctly entered, but that is the flag. I am ready for Freddy. So Freddy is one of our monster serials. Turns out there's an alternate way to do Serial Killer 01, and that is you can debug it. And so I've pulled it up here in IDA, and what I've done is I've gone to View, Subviews, Strings, and then it shows you all the strings that are in the program. And so I do this sometimes because it's hard to find the entry point sometimes to some of these programs. So if you select one of these strings here and like double click it, it'll take you to the address. And here's some of the strings that are being shown in the program. So I'll just pick one of them out. Bumpy Hassan loves Halloween. Let's do X. Or sorry, if I select the little string right here, it'll give me cross references to, and it gives these weird names for these string kind of like sort of symbols or variables. But if you select that and hit X for cross reference, it shows you where it's being used. And then I just double click it, and then it takes me to the proc, which is the main program where that string is being referenced. So here we can see the main bit of the program, and here's the strings being processed, and here's this string right here. We don't have to know much about what's going on. The main thing to do is to come down here and find this. Sorry, that's not Bumpy Hassan's favorite. And that's the branch that we don't want to take. Now, this won't work for all the reverse engineering that I've done, because some of them I've put the decryption of the key parts, that like the password is a critical part of that. So it won't work for all of them, but you can come in here and then you can put a breakpoint right before this branch goes down to sorry. And so what we're going to do is we're going to run the program, put in anything for the password, or for the serial rather, and see how the branch is flashing and it says, sorry, that is not the Bumpy Hassan favorite. So what I'm going to do is just select this line over here, right click and say set IP. I'm going to do one step, and then I'm just make sure that at the end of this branch I have a breakpoint on the return so I can stop it so the window doesn't go away. And then I'll just hit continue. And then it's going to wait there for me to end. And just go to the window here. And then there's the flag. So I don't think that'll work for all of them. It better not work for all of them because I put a lot of work into it. And I want somebody who knows this trick to be able to just flow through all of them, because there's some pretty clever things I've done with some of the other ones. So yeah, there are some that are dependent on the password being entered correctly. So there you go. That's another way of doing reverse engineering Serial Killer 01. Okay, we're going to take a look at Serial Killer 02. Hopefully I can get through this before the lawnmowers and weed eaters get right in front of my house and drown me out. All right, so Serial Killer 02. Lucifer can be a bit troublesome sometimes, but she can put away the sugary monster cereals with the best of them. She has a favorite too, and it's based on her favorite monster. See if you can figure it out. Select a binary for your preferred platform. Okay, so once again, I'm going to use Windows. And what we're going to do is we are going to download and run the program. So let me go to Windows PowerShell. So we're going to run RE02. Lucifer loves Halloween, so she too loves spooky cereals. She has a different favorite villain from the 70s and 80s horror movie. So let's just go ASDF. I'm afraid that's not her current favorite monster cereal. She's kind of capricious, you know, so it changes often. All right. So what we're going to do is we are going to pull this up in IDA. And we're going to inspect the program. We see a few strings up here. Incorrect. I'm afraid that's not her favorite. Lucifer also loves Halloween. Different favorite, villain, blah, blah, blah. Scroll down a little bit, and we see an interesting function here called decode string. So I'm going to click into that, and we're going to see what kind of decoding is going on. So it's a very short function. It's basically a big loop. We'll come down here. We'll see real quickly that we're doing an XOR, probably against the user password. So when they enter the password, they XOR it against something to see if, in fact, that is correct, the correct answer. So what is the comparison that comes back out of the decode string? Well, they're going to compare the first 12 characters correct and 1, 2, 3, 4, 5 exclamation points at the beginning of the string. And if that correct comes out, then that means the string is correct. Now, we're going to take advantage of the fact that XOR is a reversible function. And so what we're going to do is we're going to find where the flag is in memory, and then we're going to XOR that against correct and 5 exclamation points. So I'm going to put a breakpoint right here on decode string, and I'm going to run, or debug rather. So we'll debug and we'll put in A, B, C, D, so we know where to look, and we hit our breakpoint. So if we move our mouse over EAX, over ESP, we can see that ESP, it's moving the address of the ABCD string we just entered into ESP. ESP plus 4 is the length of the string comparison, so 3F characters. And then we have the next one, OCH. So if we look at that one, there's an address in there. So what we can do, and actually the one we're interested in is actually ESP8. So this is going to be like the output string, and this is going to be the input string at 08. So it's the third parameter being passed in. So the way you can go to that address, the ESP register, is you can click this little arrow right here. It says jump in disassembly. And then down in the hex view, it'll take you to that address. So we are interested in ESP plus 8. So we're at ESP right now. So we have 4 bytes for ESP, which is the address of the password. We have the second parameter, 3F, which is the length. And then the third parameter is what we're interested in. Let's just type that in. So we have 0005 A0 D0. So 0005 A0 D0. So that's our address we want to go to. Okay. So now we can hit go again, and then we can put that address right here. And then say OK. And our first number, we could have checked it when we were in the function for comparison, but our first character we were interested in was 08. And so we're going to grab, since the buffer size is 3F, that's one shy of 40, which is 64 characters, so 63 characters. So let's just I wish they had a way to copy this. They might. I'm going to just do save to file, and I'm going to call it REO2 flag bytes and save it. Let me do it on a different file. So save to file, and let's just call this 2. Okay. Save. Okay. Now let's pull it up in. Let's pull this up in CyberChef, bytes, and we saw in IDA that it's comparing the string with correct, and then 5 exclamation points. So it's comparing 12 characters against the encrypted flag. So if we go to CyberChef, and we have our flag right here, we go to our key and we type in correct 1, 2, 3, 4, 5. that means these were the bytes. This is the output that we're comparing against. This is our buffer that we copied in and we loaded into CyberChef. And then that means this has to be the password, because the password XORed with the buffer will provide correct, right? So let's take this password right here, copy that, and drop that up here into XOR. And then you can see that that decrypts our flag. So this is our correct flag. Flag, Grandpa Krampus is coming for the bad kids. Bang, bang, bang. Okay. Hope you had fun with that one. It's a little bit difficult, but I mean, with a little bit of debugging and seeing right here, basically gave you this here so that you could get the password out, and you have to just know that XOR is a reversible function. And that is it for Serial Killer 02. Okay, let's take a quick look at Serial Killer 03. DEADFACE is rather paranoid about sharing personal information. He has a favorite cereal, but he doesn't want to share that information with the government. You're going to have to work at this one a little bit. So we'll start off with the Windows binary. There's actually two different ways to solve this. So I'm going to start off with probably, well, you have to do one thing first, and it can split off into two different ways of solving. So let's actually do a strings on reo3.exe, and let's pipe that to less. And you see it's written in Go. These are going to be a lot of garbage in here. I'm just going to jump to the hint, and we're going to go to HTTPS. We'll look for a server here. Let's try HTTPS://. You'll notice if you do any kind of Wiresharking on the server, or if you just notice like a network spike or something, or by going through strings and investigating, you should eventually figure out that there is a web server being touched. And it's really hard to make out the string in Golang, but there it is right there. https://serial.littonlabs.org. So let's copy that URL. And let's go to the page. And we get this really spooky warning here. Abandon all hope, ye who try to enter here. Only those with the correct codes will be allowed to descend into the lower realms. Okay, so the word codes is capitalized. That's a hint for one thing. Let's take a look at another hint in Ghost Town. Let's look for the word passwords. Uploading Halloween passwords file. Hey Morticia, did you get that Halloween themed password file uploaded to the server? If not, make sure it has a .text extension on the end of it so that our automated cracking tools pick it up. Already done. Okay. So what we're going to do is we're going to use dirbuster. We're going to run dirb against that server URL that we found. And since we found a clue for the text file, this one might take a little work. You might have to try different things, but once you figure out that there's a server, try poking at it with different things. But the Ghost Town thread gives us a hint that there's a text file up there. So we let this run a little bit. You might not be shocked to realize that what we're looking for is a file called codes.txt. Codes being the hint that was on the main web page with the capital letters. So in a moment, and codes.txt is in the default dirb password file. So in a moment, we'll come up to the C's and we'll get codes.txt. Any minute now. There we go. we can stop it there. So now we can get this file codes. Okay, so now we have the file codes. And let's run derb again against the web page, and this time let's use codes.txt as our input file. So we find a directory called Phantasm. It's going to. So the other thing about that hint, it said you need codes to descend into the lower realms or whatever, lower levels. Well, we're descending down into the directories. So I kind of left some somewhat subtle CTF-y type hints for you. And so now we're in a directory called Wraith Apparition. That's all it's going to find. So we'll go to that directory and we'll open up a browser on that directory. And we see here in the directory, we have a file called json-image.jpg. Click on that. We have Jason Voorhees, and he likes his machete mateys. So that is the flag right there. Okay, so I said there's two different ways to solve this. I would really love to know if anybody comes up with a second way of solving it. And what we're going to do here is I've actually, for some reason, I can't get the Linux binary to run on WSL. It's 32-bit. I've done everything that it says you're supposed to do to run a 32-bit binary on WSL, but it's still not working. So I've SSH'd into another machine of mine with Linux on it. And we copy word list to codes.txt. And so what we're going to do is RO3, there we go. Okay, so we already have our codes file downloaded. And we have our bin. So what I'm going to do is I'm actually going to try to use this codes.txt as a password. So if we try to run reo3.bin, DPAX's favorite serial is password protected, incorrect. So let's try to do this instead. Let's try to do for I in cat codes.txt do echo I, pipe it to reo3.bin, and do it done. So we're going to try every word in codes.txt, and we're going to pass that as our password into reo3.bin. The thing is that when it comes out like this, each one has a carriage return line feed at the end, or a line feed, a Linux line feed, which is going to be what we want because we hit line feed at the end of entering a password. So it should come back as a whole bunch of incorrect sorries, but also we get this line right here that says the JPEG image has been downloaded. So you'll see right here you got JSON image.jpg. And if you look at that, it'll have the flag on it. So you actually have two separate ways you can use this codes.txt. You can use it to do the traverse the directory structure, or you can use it as an input as a password into the program. So I hope you enjoyed that challenge as much as I did in making it. Thanks for giving it a shot. Okay, let's take a look at Serial Killer 04. Lilith is not too old to have a favorite monster, ghoul, demon, phantasm, poltergeist, creature, extraterrestrial, or a favorite sugary breakfast cereal. She also has a favorite programming language, which no one else at DEADFACE likes that much, and they all think she's kind of weird for it. She probably mainly likes it because it was her first language she learned at the age of 9. See if you can crack her program and figure out what her favorite cereal and entity are. Okay. So when we go to the download file, we get this cenobytes.jar. So of course to run that, we would do a java-jar cenobytes. And of course you need a JDK. Probably you need the most updated version of the JDK to check it out. Lilith's favorite cereals are also her favorite monster, ghoul, demon, phantasm, poltergeist, creature, extraterrestrial. To get both answers and the flag, enter her entity with special characters as password. That is not the correct monster cereal password. Try again. Okay, so turns out there is a cool application called JD GUI that lets you decompile Java programs. So that's exactly what we're going to do. We're going to decompile Cenobites. Class, Cenobites, class there. We go into the main function. All right, what a mess. We have some static strings. We have one called keepbal. We have amho, and amho. Okay. I don't know if you're curious as to what those are. They're actually Korean words. Keepbal means flag. Amho means password. So you have a password and you have a password. Okay. So we can see here that we are doing some decoding with Z85 and RFC 1924 decoder, which are both versions of base 85. And then we're simply doing we're doing a couple of XORs here, right? So the amho or password is DEADFACE. So we can kind of infer, and we can look at the code and see what's going on here, is that they're going to decode, we're going to decode the password, Z decoder. We decode the password into this bytes, right? And then we XOR that with the password, with the bytes of amho. Okay? So basically, this is just an XOR of DEADFACE against this guy after this has been turned into bytes from base 85. And then we're going to do the same thing against the flag with the results of this right here. So let's go to CyberChef. And the first thing we want to copy is we want to copy the amho. So let's copy that. Go to CyberChef and we'll drop the amho up here. And then let's do a base 85 decode. We drop that up there. And we selected Z85, which is what was shown in the code. Let's go back and take a look at that here. So to decode that, it was the Z85 decoder. So we selected Z85 decoder. We made sure that this character here was clear and removed non-alphabetic characters. And then we XORed that with DEADFACE. So now we have our password, shark 123 bang. Okay. So now we have that available to us. So let's take the big long string here, the keepbal, and then I'm going to drop it into CyberChef here, and then remove these last few bytes off the end from the curly brace, so that caret 3 is supposed to be there. So now we want to decode this. So we joined Z85. Let's do IPv6 for this one, and now we have some output here. Let's turn that into shark. And we get this. Now what is that mess? Well, it looks like it's significant, so let's copy it. And then let's paste it into Notepad++. Well, it's still kind of hard to read, but let's zoom out a little bit. And we have flag, October is Shark Month. So that is the flag for Cenobites. Okay, I hope you had fun with that one. Thanks for playing. Welcome back, and we'll look at Serial Killer 05. 10 points. This one's really easy. We think Dr. Geschickter of Lytton Labs likes to use his favorite monster cereal as a password for all of his accounts. See if you can figure out what it is and keep it handy. Choose one of the binaries to work with. So we're going to work with EXE. Keep clicking on my OBS Studio window instead of the window that I went to. So we're REO5. So let us do strings on REO5.exe. Let's look for anything unusual. So we'll go back up here a little bit. Okay, we have a not flag. You guessed it. This is not the flag. It's not even spelled flag. It's F1 AC. But we have this weird string right here, xenomorphs, mellows, and that's one of our monsters. So we're going to just try that as the password on this program. Dr. Geschickter, just because he's evil doesn't mean he doesn't have a favorite cereal. Please enter the passphrase, which is based off his favorite cereal and entity. Well, of course he likes, he likes the xenomorph. Yeah, well, that makes sense because, it's kind of like the Demogorgon a little bit. Okay, and there you go, flag Xanadu, do. I don't know if that makes any sense to anybody. If it doesn't, Google Olivia Newton-John and the song Xanadu. Xanadu. And yes, I'm old enough to remember when that came out. Okay, so anyway, that is REO 5. That was easy. That was a 10-pointer. Shark bites. Hope you had fun. Now, there was a hint. See if you can figure it out and keep it handy. So keep Dr. Geschichter's password handy. We will be seeing it later in another challenge. Thanks for playing. Let's take a look at Serial Killer 06, worth 500 points. Dark Angel has a favorite cereal, but don't expect him to tell you what it is. He is a mercenary hacker that contracts to Lytton Labs, so he's extremely paranoid about protecting all of his personal information, even his favorite cereal. He treats it like a closely guarded government secret. Choose the binary you want and proceed. So let's run this. Dark Angel is not only a mercenary hacker with no scruples and compassion, he's also disagreeable. He thinks he's always right. Suggest you not jump to any conclusions, just walk away from this challenge because there is no solution. You can't win an argument with a black hat hacker that engages in sophistry. Don't say I didn't warn you. Enter a password. It's going to tell you you're wrong. Wrong. That's all I've got for today. Go away now. Okay. So let's. I've got this pulled up in IDA already, and we get our graph here. So let's just take a quick overview of our graph. I've got some breakpoints preset here. So what we want to do is we want to kind of like walk through and see where the flow is going to go and see where we want to kind of avoid getting into. Like right there. We don't like this block here because it's an early exit. So we don't want to take this branch right here. So when we get to this jump not 0, we can set our IP to be right there to not go down this branch, which is going to just dump us out. File IO writer, that looks like the one that just writes out the message and says, sorry, you can't, I'm not going to tell you what to do, right? I'm going to tell you what the flag is. So we want to go down this branch. And then from here, we'll see where that leads us. Okay, so let's just start the program real quick. Just enter anything for the password. Right? So we can see that it's going to dump us immediately into this block right here that we don't want to go down. Right? So what we're going to do is just right click on this instruction here on this branch and say set IP, and then we're going to step over. And now we come to another branch, and this one tells us that we are going this way to get dumped out to another quick end branch. But if we come over to this branch over here and inspect it and start looking what's going on, we start seeing some cool things going on. So we have a hex decode. We have some slices of arrays. Come down a little bit lower. We should see some really cool things going on right here. HTTP client get. We see a read all. We should probably see that decryption. We got a crypto, MD5, digest write. So there's a lot of cool stuff going on. This is the branch we want to take. So this is where all the action is. And so we put a breakpoint right here at this return to catch the window so it doesn't close, slam shut on us. Okay. So we're going to go ahead and run this. So I entered the string. It comes back and says, Dark Angel says, optimize my code away. No, you don't. That's not significant to you. It was to me. So we took that branch. Actually, no, we're about to take this branch to go down this dead end. So what we're going to do instead is we're going to come over to this guy and we're going to say set IP, and we're going to continue walking down the path. And if it jumps out to one of these guys here, one of these runtime async preempts, I just jump out of that function and say single step to get back to where I was. They happen once in a while. I'm not sure what it is. It's something going on with the Go runtime. I just get out of those, a couple of them. There's like usually 2 or 3 of them in a row. And then I get back to my space here. And I see now that looks like I'm going down the path that I want to go. So I'm going to hit the continue button. And it stops at the return just before the end of the program. So if we go back over and look at our dialog, wow, you beat Dark Angel. The flag is flag Xeno and Xeno, meaning the xenomorph and xenomorph are BFFs. best friends forever. So there's your flag. You could have done it this way, or you could have tried to go in there and just modify the binary to set the J and Z to a JZ. Unfortunately, the free version of IDA doesn't let you get away with that. You'd have to like find the absolute address in the file and go change the opcode with a hex editor, which is okay. But I kind of like with the debugging being able to step around and go exactly where I want to go. And I love IDA the way it shows me the pathway through. I don't like IDA's price. I'd much rather use Ghidra. I haven't used Ghidra in a while. I need to take another look at it. But this tree view in both IDA and Ghidra cannot be beat because you can really get a good look at it and see where your code blocks are going and which ones you want to avoid. And then you can just step past that nasty code. In case you're wondering what the password's doing, it's actually doing like a SHA-512 sum of the password and checking to see if it equals 0. And that's why you'll never enter a correct password unless you just happen to get, the one correct password that's 2 to the 512th, bits. See, that's where it says right here, you'll never get here. The odds of you landing here are 1 in 2 to the 512th minus 1, which is true, except we just did a walk around, the if statement to check for this condition. So there you go. I hope you had fun with that one. I had a lot of fun with this one, making this one and coming up with it, and challenging you to hone your assembly language skills. So we'll move on to the next one. Okay, let's look at syncopated beat. Syncopated beat. We know there's a hidden message somewhere here, but none of our tools are able to reveal it. Steg tools are able to reveal it. Can you think outside the box? It's a well-known fact that rock musicians are all non-incarnate conscious entities, or nice influenced. Nice speak lyrics to them and insinuate their evil messages. Okay, so we want to download the zip file. And we open it up. And there will be 2 files inside there. Let's go ahead and make a directory for this here. This is Stag05, I believe. And we'll just drop our files in there. All right, so we take a listen to syncopated beat. Okay, it jams out for a while. So let's go to about minute 2. Okay, so this is a throwback to the 80s. I did one like this a couple of years ago. It's a throwback to the 80s and the backwards masking craze that happened back then, where supposedly rock music had backwards songs in it, or backwards lyrics recorded backwards. So what we're going to do is we're going to drop the syncopated beat here, and you can see real easily in Audacity the transition to the demon voice. So we just select that there, and there's up here there's effect, special, oops, not repeat, but we want reverse. Effect, special, reverse, and we put our cue right there, and we go ahead and play.
Time is reversible, but the music does not. Go back, go back.
Time is reversible, but the music is not. Go back, go back.
Hey, I remember you. Well, it won't be that easy this year.
Hey, I remember you. Well, it won't be that easy this year.
You need to get the Stego program used by Elliot and Mr. Robot.
You need to get the Stego program used by Elliot and Mr. Robot.
and use it on the audio file linked in the challenge.
And use it on the audio file linked in the challenge.
The password is the name of the new CTO of Evil Corp.
The password is the name of the new CTO of Evil Corp.
All caps, no spaces.
All caps, no spaces. Okay. So we're going to take that second file, and the name of the program used in Mr. Robot is called it's called Deep Sound, and I've installed Deep Sound, and we're going to drag and drop this mysterious wave file. I don't know why it sounds so scratchy in the beginning. Maybe it's some settings in Deep Sound. It shouldn't sound like that, but that's where it's modifying the actual bits of the music file. So I'm going to take that and drag it and drop it here. And the password, the new CTO, the one who, so everyone got hung up on Terry, I forget his last name, was the first CTO. Scott Knowles replaced him, but then he was replaced by Tyrell Wellick. So let's do Tyrrel. I think it's one L. No, I think it's Tyrre. Nah. Let me just Google it. I think I got it right. Tyrrel Wellick. So this it's one. Okay, so it's Tyrrell and no spaces. Wellick. Okay, so then it dumped this file here, and I think it just dumped it. Let me just try to extract secret files. Okay, so it saves it to documents. So now if I go to documents and date modified, Ozymandias, there's Ozzy Osbourne. In case you don't know who he is, he was the lead singer for a band called Black Sabbath, and he was infamous for supposedly biting the heads off of bats on stage. So look out, COVID bats. And there's the flag for syncopated beat. Hope you enjoyed it. The Wisdom of Knox. So the Wisdom of Knox is a poem, and then it has a link to the full poem here for the download file. And if you do that and you take a look at it in the browser, it's all messed up. If we look at it in Notepad, it's got that same kind of gobbledygook characters there at the end. But as it turns out, if you look at it with the Linux tools, and the hint said something about try using Linux tools before jumping right into CyberChef. Uh-oh. Oh, I zoomed in. Okay. So before diving into CyberChef, it said to use the Linux tools. So let's take a look at. So the walk.txt file, let's just do cat on it. And it already removes the high byte for some reason. I think it's just showing the ASCII, so it just truncates those. But let's do a hex dump -c on walk.txt. And at the end, you can see this line in Latin, which says the secret flag is below, basically. And then the string here with the high bytes all set to 5. So you could go through here and edit the file with a hex editor, change all these high bytes to 0 from 5, because this file is in Unicode. But cat already does that for you. So once you've done, cat, then you can just copy the string right there, and you can go to CyberChef. And this turned out to be way easier than I expected it to be. So what we're going to do is we're going to paste that up here. And then we can just do so we can try Magic on it. Magic does a lot of decoding, and it says matching from base 58, from base 85, base 64, valid UTF. Now, if you just come up here and click intensive mode and extended language support, it actually does a whole lot more stuff for you. And you can scroll down here and you can see like it basically found some, basic EBCDIC encoding, which is an old IBM format. But if you scroll down a little bit, you'll find one that kind of closely matches up with what we're looking for. So right here, this one is Latin one. It's got bars for the exclamation points. If you submit it like that, it'll actually work. But if you scroll down a little bit further, you'll find those as exclamation points in some of the decodes right here. Like, so say for instance, international, it comes out with the flag. Why? Because we are elite hacksaws, hack the planet. So that's your flag right there. So that one actually turned out to be pretty easy as long as you knew about magic and turning these on. And if you just go to google.com and you search for Cyber Chef Identify Unknown Encoding, you can just go to that first link, automated detection of encoding using that, and then magic byte detection. It'll tell you all about that. Right? So gives you some information on how to do that. So that one's actually, I thought it was fairly simple. It's only got 15 solves. I guess maybe there's a lot of people that don't know about Cyber Chef Magic Mode. You can do it manually by decoding from base 58 first, and then figuring out the EBCDIC. That one's be a little tougher, but yeah, Cyber Chef makes it all easy. Okay, hope you enjoyed it. Okay, so now the Pearl of Wisdom of Eliphaz. There's a poem listed here, and then there's a link to two different images, the Pearl and then the Wisdom of Eliphaz. So if we click on Pearl, we get this image right here. Guy screaming at the ghost that's at the foot of his bed. And then if we go to the second one, we get this more traditional painting of the story of Eliphaz and his friends. So I've downloaded those. And if we take a look, we can actually, so it's eliphaz.jpg. We can actually just, we can look at the EXIF data, or we can just do a strings on Eliphaz. Strings Eliphaz, do a less on that. And you're looking for something unusual in here. Like I said, it's in the EXIF data. So if I just do a search on HTTPS, we come to this URL right here. HTTPS, tiny URL, and then this set of letters. There's also a Latin phrase in here. Sequera viam superius ad invenidium margaritam sapientiae. So if you drop that into Google, it'll say something along the lines of follow the above to the path of wisdom or some such thing like that. So basically that's just to tell you that, hey, this is your next step. And Latin, because it sounds spooky and it's Halloween, right? So when we go there, oops, we got an extra character at the beginning. When we go there, we get this Perl file. And let's open this up in Notepad++. And we get this cutesy little piece of something here. Well, it's a .pl file. And .pl, it kind of tells you that it's Perl. So the Pearl of Wisdom, right? And then you got some comments here. The first is PW equals question mark, Arcanum ex verbis poematis creatum, which means a secret created from the words of the poem, right? And so this is going to be your secret that's going to unlock the next stage. Fons veritatis means the source of truth. And then we have a regular expression that's our password has to match. And if it matches this, it says veritatis, which means true, and mendacium, which means falsehood or lie or false. Okay. Paulo plus auxilium means a little bit of extra help. So A equals $2 and B equals $3 means we're going to grab the section in parentheses. So $1 refers to this first section here in parentheses. And then we have a special character followed by the second set of second word, followed by a / parentheses, which means literal parentheses, followed by a number of 4 digits, followed by a closing parentheses. So if it matches that, it's going to be true. However, we further limit what can be done by noticing that the second word, or the first word A, or sorry, the second word, because it's $2, has to follow this pattern. So we tighten it down a little bit. Instead of A through Z, we have A through P. So the word has to start with the letters A through P. And then you have 3 more letters, and it ends in the letter R. And if it matches that pattern, you get veritatis, and then circumscribere dolor aliquantum. Means limiting the pain somewhat, I think is what that means. So we're given here that it's a literal that starts with 20. So it means the 4-digit number is going to be limited between 2000 and 2099 in parentheses. Okay. So once we have our whole password, we can plug it in here and make sure and run the Perl program to make sure it actually works. But before we get there, I'm going to show kind of how I did this. I am going to show you, there's a script file that I put together. So nano make list.sh. All right, so I apologize if this is a little hard to read, but the first line here is, it's really hard to read. Let me try to cat make list. There we go. All right, so the first line says, create the list of first word candidates. Ignore the case while selecting, then upcase. So the words of the poem, okay, well, first of all, what I had to do is I had to create the words. Let me find the list where I did that. There's a grep here. And to create the initial word list, this is what I did right here. So grep-o-E/W plus poem sort-u-f out the words. And what that does is that splits the poem up into individual words with no punctuation or anything like that. So you just get individual words, and that goes into a file called words.txt. So if I do words.txt, we have all the words sorted in order, okay? So that's how I created my words. Then I, in my script here, what I do is I use that word list and I pull out the individual pieces and drop them into individual files. So grep-e means using extended grep format, and -i means ignore case. So even though I'm telling it to look for an uppercase character, I know that in words, not every word has an uppercase. So I say just ignore that, okay? And then that's going to do that on the words, and then that's going to pipe the result out to the sed command, which is going to uppercase the very first character, and then because that's what the regular expression calls for, and it's going to drop it in list 1. So just as a demonstration of what this ends up looking like when you run this. So we get the words righteous, trembling, and unnoticed. Okay. The second line, Python characters.py. That's really simple. All that's doing is just printing the punctuation. So if I do Python 3 cars.py, it prints out all the special characters in their own line. Right. And then the third line is going to match the third regular expression. And it's going to upcase, it's going to ignore case, and then it's going to upcase the first character. So that's going to match this part right here, where it looks for a word that ends in R and starts with an A through P. So if we do that, we get 2 words, error and maker. All right. And then for the third one, I'm just doing a loop, and I'm creating all 2,000 numbers, or all 100 numbers, 2,000 to 2099, surrounded by parentheses. Done. Okay. And then I have this little script right here that is like doing an outer loop to an inner loop, and then it's just merging them all together down here in this echo 1 line. So when I run this, it gives me all possible combinations. Okay. Now there's this great program called stegseek And if you go to, if you look for StegSeek, it's actually, I guess I just downloaded the deb file and installed it. But this is supposed to be a really super duper fast program for cracking Steg passwords, and it's also got a vulnerability where sometimes you don't even need a password list and it can crack. Really great program. So I'm going to tell it to work on the second file, the traditional painting, Wisdom of Eliphaz. I want it to use the word list all passwords, and I'm going to extract out to the text file woe.txt. It already exists. Bam, it's done. Okay. So if I do a cat on woe.txt, there's our flag. Oh, why should the spirit of mortal be proud? They shouldn't. Well, except for us hackers, because we're really super elite, right? If you saw the other flag from the other wisdom poem. So yeah, it's a little bit crazy. Like it's the first stage will get you to the wisdom of the pearl of wisdom, but you got to really kind of have to know Perl or understand regular expressions. You could take this password and test it and see if it works by, so if you just go into nano Perl, I want to just show what I did here. You can just replace it into this thing right there. If you think you have the right password, and then if you do perl.pl, you get 3 Weditatis, which means true, 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 which means it passes all 3 tests, which means this password is a legitimate candidate, right? But remember, we had all these legitimate candidates that we would then use as a list of passwords against the second file with StegSeek to crack it. I hope you enjoyed it. I know it's a bit of a headache. A few people have solved it, but it's kind of tough. You have to know Perl, have to understand regular expressions, steganography a little bit. But yeah, anyway, on to the next one. All right, terms and conditions. This was one of my favorite ones to put together. I really enjoyed this. Had a lot of fun making it, and I hope some people had some fun with it too. It could be a little annoying, but okay. So terms and conditions may apply as talking about this concept called predictive programming, where bad guys sell their souls in exchange for power, but they got to warn everybody what's coming. And so they do that in the form of these sigils or these secret symbols, right? And so there's a video discussed on Ghost Town that appears to have such a hidden message. So if we go to Ghost Town and we find a thread called predictive programming, Lucifer is discussing predictive programming, how it works, why certain events you see on TV were mimicked in books and literature from before, and that was the bad guys trying to warn everybody what was going to happen, but they're too dumb to know that's what's going on because they're not paying any attention, right? So this whole discussion, falls in around that. And then down here, the Zealot pops up and says, funny you guys should bring this up. So it appears Lytton Labs is going to be opening a new academy after we got them shut down. I found this video online about the new Lytton Labs Academy, and there's the link to it. I watched it through a few times. Some of the video is old, so at first I thought the artifacts in the video were all from these old Super 8 cameras or were cutscene symbols you often see in old TV shows or movies. But then I started thinking that there might be something more to them since they also appear in the newer sections of the video. Check it out and see what you think. Okay, so I'm going to play probably about maybe a minute or so of the video so you can see what he's talking about with the symbols. So you're going to see symbols flashing on the screen for about a fifth of a second. That's right. So they're all black and white, stark black and white, and they're all like square and angled and stuff. So you'll see another one here. Right there. Okay, so this was supposed to be an advertisement from Lytton Labs for their new laboratory that's coming up, and they're showing some scenes from Halloween in the past and Halloween just last year. And, it's supposed to kind of like lighten your mood and help you get into the Halloween spirit. But also these little symbols, you probably recognize them as pieces of a QR code. So you collect all 16 of them. There's 16, and that means it's a 4x4 matrix. And you put them in just in order, 4 across, 4 across, 4 across, 4 across, and then take a picture of it with your camera, and it will lead you to a website called https files.littenlabs.org. Okay, now this is important. It's not part of this challenge. The challenge says take the secret message, which is the URL. You can do files.littenlabs.org http:// or https, and then the URL. That's the flag for terms and conditions. Once you do that and the phase has kicked in, bonus O2 unlocks. And that's when the one that's going to be discussing what to do with this web server, what they're looking for. Okay, so that's the end of terms and conditions. It was just a matter of getting the QR code, getting this URL, putting it in with the flag tags, or flag, curly brace, the URL, curly brace, and entering it. And that is the flag for terms and conditions. And it leads you to this website. I hope you enjoyed it. I hope you had as much fun watching it and playing it as I did in making it. Litten Labs, dark sarcasm. Or, how can you have any pudding if you don't eat your meat? It's a reference to Pink Floyd, Brick in the Wall, if you've never heard that song. Awesome song. So Litten Labs is opening up a new academy on Halloween 2023. They had to abandon the old building after they kidnapped the Zealot, and he managed to escape from their Dr. Geschickter. It's a little flag right there. Stephanie W. and Darkgate, not a flag, but a hint. Cleaned out any trace. So we have reason to believe Litten Labs is running a secret server that has information that could be of use in exposing their evil activities. Finding it's going to be a little tricky because we believe Litten Labs is using advanced techniques to communicate the location of the server to each other. That's the video, right? That's the terms and conditions may apply. We know that DEADFACE has an interest in collecting information from the victims, and that they want some information on the Zealot. He's interested in how they try to recruit him. So we need your help to find out the actual name of the handler that Litten Labs used to try to initially recruit the Zealot, Daniel Savold, into their fold back when he was in high school. So it requires some digging around Ghost Town and other challenges to locate the server and to collect the information. So you want the name of the handler, flag, first name, middle name, last name, all uppercase, spaces, and the flag tags. Okay, so once we get to this page, files.littenlabs.org, which we found from terms and conditions may apply, you take a look at the usernames. There's several usernames: Angel Johnson, Brandon Lance, Carolyn Heck, Charles Geschickter, and some others, okay? And a login button. Now, you could get in one of two ways. So the first way, and this is one a lot of people seem to have some difficulty with this one, but going all the way back to reverse engineering serial killer 05, we'll see this text in the challenge. We think Dr. Geschickter of Litten Labs likes to use his favorite monster cereal as a password for all of his accounts. See if you can figure it out, what it is, and keep it handy. Okay? We put that right on the challenge so that you would know, once you find Dr. Geschickter's password, look for a chance to use it somewhere else. Okay? So Dr. Geschickter's password was, give me just a second. It was the same one used to unlock the serial program, which was Serial Killer 05. And so what it was Xenomorph Mellows. So let me just paste that here. Xenomorph Mellows. Okay, that was his password to unlock Serial Killer 05. So now we'll take that and we'll go to the login page. We'll select Dr. Geschickter, and then we will paste his password, and we are logged in. Warning, you must encrypt every file before uploading using the password generated for you by another fine product brought to you by version 2.0. You must also use the official Litten Labs crypt program, littencrypt.exe or littencrypt.bin for encryption and decryption, and then some rah-rah about Blowfish. So what you're going to find, we'll get to it in a second, but here's your encrypted files you're going to be interested in looking for. Okay, so you can download these, but you need to decrypt them. In order to decrypt them, you need to get the passwords. Okay, so now we have a hard time getting anybody to run this tool, DERB, against any of the websites. Everyone seems to think that it's not okay to run this. And we specified in the chat multiple times that it's okay against challenges that I've created and ones that belong to DEADFACE. So what we're going to do is we're going to run DERB on files.littenlabs.org. And we're just going to run it raw like that and see what we get. So DERB, what it does is it looks for directories or files inside of a website that don't necessarily have direct links to them. So if you want to find like a secret login page or a secret text file with passwords in it, or backup files that people have left strewn around the server, this is a great way to do it. So what it's doing right now is, since we didn't specify an actual file extension, it's just looking for directories. So what it's going to do is it's going to keep running here. It's a little slower than I like, but I could have truncated the list a little bit. But it's using the default list right now. It comes with DERB. And in about a minute or so, I'm just going to pause and come back. Okay, so what we see right here is we got a hit on files.littenlabs.org/files. Okay, so we're going to go there and see what we find. All right, so we find several things: a README file, a login.php.back, the lit encrypt that was referenced before, and this afbpbtyb.exe. So let's take a look first of all at readme.txt. All files must be encrypted with lit encrypt bin exe. You will likely need zlib DLL with the Windows version. Files encrypted by lit encrypt will have an extension of .lcr on them. If the file does not have the extension, it is not encrypted. Run the file on the LCR file and provide the password used to decrypt it. The encrypted LCR file will be deleted and replaced with the unencrypted version. Use the password generated for you by another fine product brought to you by, that's the afpbtyb.exe, written specifically for us by our friends from Macro Squishy Labs. This password is the same as your login password to the file server. This password is extremely secure, and that it's 16 characters long of mixed types. No one is ever going to crack this password. We promise you. It is imperative that you follow security protocol, DEADFACE and Turbo Tactical, these dweebs. We need to keep them out of our business to effectively use our massively superior intellects and complete lack of moral scruples to create a better world. And whoever is responsible for leaving these .back files all over the place, you had better remove them, or else you will face the fierce wrath of HR and Dr. Geschichter. Okay, so that means let's go take a look at that one next. Login php.back. And we can open that with, let's go with Notepad's good enough. Okay, and so here we see an alternate of the login program, a backup file, and it references this a SQLite file called lab.database.db. I'm going to assume it's in the same home directory as the login page because there's no path to it. And then there's a username from there that populates the drop-down list. So let's go grab that file. So we can go to /lab_database.db. That downloads the file. And we can actually, in WSL, we should be able to open this up. So, are we? Downloads. Let's do SQLite 3 lab database. And tables to list the tables. Users, select star from users. And we see, we have some hashes here. Right? So there's one for Geschichter, and there's one for the other users in the list. So you could log in with any one of these passwords. So what that means is if you don't remember Dr. Geschichter's password, or you don't remember that you got it, or somebody else in your team got it, and you've long forgotten, if you got to the files directory, you would find this, and any one of these passwords will get you into the website. So then you could look at the directory with the .lcr files. The /files is open to everybody. You don't need that. You don't need any of these passwords to view that, right? So what we want to do is we want to get all these passwords, and we want to crack them. Okay. So how do we do that? Well, if we go back and look, we remember that we were told that all passwords have to be generated by this afpbytyb.exe. Okay. So let's run this program. And I don't know if any of you guys played last year, but you remember the little obnoxious Clippy program that got really mean and mad at you for everything? Well, so this is version 2.0. Hello, welcome. Another fine product brought to you by 2.0. With Clippy, he's seen better days. So let's go to help, go to howdy. I don't know why this takes like 30 seconds to pop up the first time I do it on my VM, but it does. If you're running on a base system, it should just pop up instantly. There we go. All right. Hi, I remember you from last year. Are you having fun? Okay, so yeah, I was a bit rude last year. Obnoxious, really. HR pulled me aside and we had a little talk with me about my behavior, and I sort of got demoted as well, and I feel really, really bad about it. I also feel bad about the whole antivirus alert thing, which we referenced before in the chat, where I accidentally triggered AV alarms, and we got one of our websites locked out because of the first version of this program. This one won't do that, promise you. Anyway, I hope to make up to you by generating a really, really secure password for you. This password will be 16 characters long, so there'll be absolutely, positively no way that anyone would ever be able to crack it. That's your invitation right there. The passwords are so secure that even the esteemed Litton Labs uses our software to protect the sensitive documents from prying eyes. Go ahead, give it a try. I hope you enjoy our new product offering. Okay, so if we go to Tasks, Generate Password, we get a random password and a SHA-1 hash for it, okay? Well, it's not super helpful for us, but let's do something here. Let's go take a look at this program. It turns out if you do a file on it, let me see here. I'm in the right directory. File. Another fine product brought to you by exe. It's a .NET assembly. So what that means is we should be able to decompile it very easily. We want dnspy, and we can decompile this program and look right at the source code and get in there and play around. You can even debug it if you really wanted to. But there's a couple of salient things I want to show here. First of all, Form 3, if we look at the initialization code here, first of all, it's going to call this generate random password and pass it a seed. And the value it's going to use is environment.tickcount ended with 1048755, which if you look in hex is going to be F. So what that does is it ands off the top 3 nibbles. So it takes this number from a possible 4 billion combinations down to about 1 million combinations. And that's the seed that gets passed into generate random password. If we go look at the generate random password program, it takes that seed, it creates a new random value once, and then uses that for every value that it generates, okay? Now, what that means is if you do look at the documentation on random, they will tell you, and you can see it right here, it's a pseudo-random number sequence. What that means is this is completely, totally unsuitable for use in things that need cryptographically strong numbers. And what it means is you pass in the same seed, you will be guaranteed the same password every single time. Now, with only about 1 million values possible, you can generate every single password by just passing in every seed from 0, 1, 2, 3, all the way up to max seed, which we saw was environment.tickcount, a 4 billion possible values with the top 3 nibbles bitten off, basically, which means you have 24 bits of password space. I'm trying to think, trying to remember. So FFFF, so that means 3 nibbles is 12 bytes, is 20. It's a 20-bit password, which is about 1 million passwords. So you can easily write a program to generate all those passwords. So let's take a look at an example of one. Hopefully I have it queued up in my, not blend. No, 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 go away. We want Visual Studio. 2017, allpasswords.sln. So what I did was I just created a quick little program where I copied and pasted the generate random password, and I pasted that code in here. I created a main where I take the first and second parameter and pass that as the max and min seed if I want to. If I don't, it's going to use 0 and max seed as the default arguments. And max seed, remember, has got the first 3 nibbles bitten off, so it's only 1,000,000 passwords. And then it's going to call generate random password about 1,000,000 times and generate every single possible password there is, along with its SHA-1 hash. And then it's going to write those out to the screen with a colon between them right here. Okay. Now the upshot of this is when this program runs, what you're going to get is really cool. If we look at allpasswords.txt, I'm not sure what 8 is. Oh, I think I know. Yeah, so I ran into this problem where when I generated it in Windows, it can't give it to me in Unicode. So I ran strings on it to turn it into UTF-8. And that's what this UTF-8 is. So I did strings dash like BE on the file, all passwords, and piped it out to 8 to get it in UTF-8 format. And so here you see we have every single hash and every single possible password that can be generated by that program. Okay? So the upshot of this is really cool. We can just do a grep, and we can go to our, okay, let's just pick one of these. So Geschichter's password, remember, is not generated by the program. He's the manager, so he does what he wants, right? So let's just look for Aram's password here. All passwords 8, and there it is. This is his password, okay? We can do the same for all of these. Let's look for Mallard. We can look up his hash. This is called a rainbow table, right? Because they're using an unsalted hash, we generated a list of all possible passwords, in this case, all possible passwords and their hashes, and we just search for the hash and we get the password, okay? Really cool. And I was really, really happy about this because this is actually from a real engagement. I actually found this in a real engagement. They were using this type of password generation. And I said, hey, I can crack every single password you have. And they didn't believe me until I showed them the program. And I generated a program that had every single password. And they had a special hashing algorithm, so I used a GPU instead of a rainbow table. But I told them, hey, look, I can crack every single password you got. Okay, so Angel Johnson is the one who has encrypted. Now, this is what you call trial and error. You have to try every password against every file. But once you figure it out, you can try it here. And so what we're going to do is I'm going to go here to, actually, I've already got the lit encrypt bin here, I think. I don't. So I need to download that. Let me see if I have it in downloads. I don't. So let me just get it here. And we'll just do the Linux one. It doesn't matter. So lit encrypt bin, and let's give it the URL from the page here. We just need the bin file. Copy link. Paste. Right. Chmod 700. Lit encrypt.bin. Okay. So now if we run this on, we need the Daniel file downloaded. So let's get the link for that. I'm going to skip the other files. They just have some kind of information about other victims of Lytton Labs. We need to go to the login page where we logged in. I don't know if it's going to let me do it without relogging in again. All right, let's go with Geschichter. Actually, I have his password selected. It's Angel. We should be able to just paste his password in here. Nope. I need to copy it again. So we just had Angel's password here a second ago. I think that was the last one we did. So let me try that. Nope. All right, let me just grab the password from my list here. Okay, so it's 98. So it was that A3C hash. I'll just log in as Angel Johnston. Doesn't matter. You can log in with any of these guys. There we go. And we'll just grab this file right here, copy, let's click and download it, just in case it would require authentication. Okay, and so I'll copy that back here now. So copy, downloads, Daniel. Okay. Did I put it somewhere else? It's in downloads. So let's copy. Yeah. Okay, now I'll just go back to my bin directory here. Encrypt, bin, and then Daniel. And it's going to ask for the password. And it's opened it. Okay. So let's go in there and look at the file. Desktop bonus Daniel S to PDF. And it gives you this really old looking document. You can read through it for your enjoyment. But it goes all the way down, and what we're looking for is the name of somebody called the handler. There's his name right there, handler. So right here is henceforth referred to as handler. So there's his name, Christopher Scott. This is kind of hard to read, but his name right here is spelled out again. Uh-oh, there's difference in the spelling. If anybody finds that, hopefully they'll come and ask me about it. Usually they do if they enter the flag and there's a difference. I will add that like as soon as I'm done with this as an alternate spelling. But what they're looking for is this: Christopher space Scott space Mannheim, and I'll put the alternate spelling in there so that works as well. And that's how you find out their evil plans. The other documents you can look at and read for your enjoyment for spooky Halloween fun. I know you're interested in hurrying to other challenges, but I hope you had fun with this one. And because it basically, like I said, it was some real world stuff that I ran into, and then a lot of other techniques that we use as pen testers every day. So I hope you had fun with it. We'll tie this up.